another cubic. So we're given y equals 3x cubed minus 4a squared x plus 5, where a is just some positive number. Find the range of values of x in terms of a for which the function is decreasing. So just a reminder, decreasing means a negative gradient. Cool. Wow, we know how to draw a cubic. Beautiful. How did I know it was positive cubic? Well, the coefficient of x cubed is positive. So it goes up, down, and then up. All right, a positive cubic. Now just looking at that, we know it is decreasing, maybe I'll use red for decreasing, between the two turning points. Right, that red section there. So if we can find the x values of the min and max point, we know that between those two values, this function is decreasing. So how do we find the x values of the turning points? Well, like always, we know the turning points have a gradient of 0, right, at that point. So let's find the gradient function. So we're given y, right, our original function. So I'll just rewrite that, 3x cubed minus 4a squared x plus 5. Let's find the gradient function, dy by dx. So we take the power of 3, multiply it out the front to give 9, and we subtract 1 off the power. Now this term looks a bit odd with the a squared, but remember, a is just a constant, so leave it as is. We're worried about the derivative with respect to x. So we have x to the power of 1, so this is similar to, for example, the derivative of 2x is 2. Here, the derivative of minus 4a squared x is minus 4a squared. The derivative of plus 5 is 0. So we've calculated the derivative. Now, what we were looking for the x values of the turning point. So we could say turning points are when the derivative is equal to 0. Right, in other words, 9x squared minus 4a squared equals 0. Solve for x. So I'll add 4a squared on both sides. Alright, we're getting closer. I will divide both sides by 9. Alright. Or equivalently, we could put the a in the numerator. So 4a squared over 9. Yep. And now I will square root both sides. So x equals, now, when we square root something, how many solutions do we get? 2, right? We get a positive or a negative solution. So square root of 4 is 2. Square root of a squared is a. Square root of 9 is 3. So we get x equals plus or minus 2a over 3. So let's update our sketch. So we'll have negative 2a over 3 and positive 2a over 3. And that's because a is a positive number, so negative times a positive gives us a negative, which is why negative 2a over 3 is towards the left, right? It's the negative number. Alright, so at this point we've worked out the x values of the turning points and we know what the cubic function looks like, so we can now answer the question. So therefore, function is decreasing for x is between, right, so x is greater than negative 2a over 3, and x is less than positive 2a over 3. Alright, so using the interval notation with the angle brackets. Alternatively, the sketch that we've shown here clearly shows, so we could even label that as decreasing. That also clearly shows the interval. Or, you know, in a sentence, it is decreasing when x is between negative 2a over 3 and positive 2a over 3. So again, the expected answer is to use interval notation with the angle brackets. Because this is reading that x is greater than negative 2a over 3, but not including, right? And it's also less than 2a over 3, not including. Whew. Right, let's summarize this one. So this question asks us to find a range of values, right, an interval for which a function is decreasing. We first acknowledged that the function was a cubic, so we sketched it. We acknowledged it was a positive cubic, so straight away we knew we had to find the turning points. To find the turning points, we needed the derivative, which is the achieved part. But once we set that equal to 0 and found the x values of the turning points, that's our merit part, and then wrapping it all up, right, writing our conclusion is the excellence point. Alright, see you next time.